Alright, let's continue on to page 416, number 15. We are going to be using a 0.05 significance level. We are testing the claim that the mean difference is different from zero. Our sample size is 31 values. The sample mean is negative 0.419. Sample standard deviation is 3.704. So the opposite of our claim is mu equals 0. This is our alternative hypothesis and our null hypothesis. So the population standard deviation is not known, so we will be using a t-test. So we press stat, test, t-test is in number 2, and the value of the null hypothesis is 0. The sample mean is negative. Make sure you hit negative and not minus. Negative 0.419. Sample standard deviation 3.704. Sample size is 31. And we should highlight not equal to. Calculate and write down our test statistic and p-value. Negative 0.630, negative 0.630. The p-value is 0.534. So as we can see, our p-value is not less than or equal to the significance level. It is not less than or equal to the significance level, so we fail to reject the null hypothesis. So we can write our formal conclusion. There is not sufficient evidence to. Our initial claim is our alternative hypothesis, so we write support. If our initial claim was the null hypothesis, then we would have written reject. The claim that, and then restate the claim. The mean difference is different from 0. Our critical value, this is a t distribution, so we're going to use t interval to find the critical value. So we press stat, test, t interval, and we're going to enter 0 for the sample mean when we're trying to find the t critical value. The sample standard deviation, the square root of the sample size. Sample size is 31, so the square root of 31. Sample size is 31. The confidence level, the critical value is in both tails, so the confidence level will be 1 minus alpha. Since the critical value is in both tails, the confidence level will be 1 minus alpha. 1 minus 0.05 is 0.95. Calculate. And we're going to have positive and negative, since the critical value is in both tails, 2.04. Positive and negative 2.04. Alright, all done with number 15 on page 416. Last problem is page 424, number 8. Alright, it says that we were going to use a 0.01 significance level. We're going to test the claim that the current class has less variation. So sigma is less variation than the past. Past statistics class have scored with standard deviations equal to 14.1, so less than 14.1. And we are told that the sample size is 27 test scores, and those 27 test scores have a standard deviation of 9.3. That's the sample standard deviation. Alright, so we're going to, the opposite of our original claim is sigma is greater than or equal to, we just write equals 14.1. Alternative hypothesis, null hypothesis. And so we pull up our calculator. We're going to use the var test program. var test, hit enter to execute. The variance we are testing is 14.1 squared. This is the standard deviation. The variance is the standard deviation squared. The sample size is 27. And the sample variance would be 9.3 squared. Significance level 0.01. And we're going to write down our test statistic, 11.31. Now the critical value is in the left tail, so we're just going to take this small value, the smaller value, 0.00560. We're going to compare that to the significance level, 0.01, and as we can see, this is less than the significance level, so we are going to reject the null hypothesis. And we can write our formal conclusion. There is sufficient evidence to our original claim is the alternative hypothesis. Support the claim that, restate the original claim. Sigma is less than 14.1. And our critical value, we will use the equation solver for the critical value, math. Scroll up for solver. And the lower boundary is going to be 0 for a chi-squared distribution. The degree of freedom is 1 less than the sample size, so we'll enter 26. The area under the curve. So critical value is in the left tail, so it's over here. So this area under the curve is going to be all of alpha, 0.01. So we're going to enter 0.01. Go back up to the U for upper boundary, so we can solve for the upper boundary. Alpha, enter. And that critical value will be 12.20. Alright, so we're all done.